Okay, this is question 9 from review set 4B. There's a formal logic to this question, which is kind of interesting, although maybe a little bit of an odd question because you know, if we know that the derivative of, so the integral of a derivative gets us back to the function, and if they said, what's the derivative? You say, well, it's the thing inside the integral. And so there's a temptation just to look at this and change those t's into x's and get the answer. But let's just go through the logic of this question in a more formal way. So we know that there's some a of x function and it equals this integral. And we're trying to find the derivative of that function. Now, the problem is that here, this function is some function where t is the input, not x. So this is an integral with respect to t. I know that if I was to use the fundamental theorem of calculus to evaluate this integral, I'd be getting f of t, some antiderivative with respect to t, and I'd be evaluating between pi on 2 and x, and that would look like f of x minus f of pi on 2. Alright, so that is all still a of x. But what I'm trying to find is the derivative of a of x. Therefore, the derivative of a of x would be the derivative of this. Right? The derivative of capital F of x minus the derivative of that, but the derivative of that is constant. Right? So this is how we can get to the point where we go back here and say, well, this is f of t, but I now want I want to swap my t's for x's, basically. We can say, well, therefore, the derivative of the antiderivative was in here all along. So it's 2 cos squared x minus 3x. So it's kind of a nice formal process, but it's almost a bit confusing in its simplicity as that question. Anyhow, it's done.